Happy solstice, everyone, and welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend.
Aww. I'm Corinne Caputo, a writer, funny person, and solstice experiencer.
You are all of those things. Every time you say funny person, it cracks me up.
I always really hesitate on that because I'm just like, I don't know how we're describing myself.
Yeah, it's one of those funny because it's true situations.
Yeah.
Mm-hmm. And hey, I am Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a bud to the universe.
Yeah.
And today we're going to be talking about things that you can see in the universe at this particular time of year. We're doing that from a cookout, from a summer. It's summertime.
Yay.
It's about to be summertime. We're here at a cookout. The beers are chilled and you can hear them being cracked open. The meat is on the grill, and the meat alternatives have already been on the grill, so they're not contaminated by the meat.
No contamination. Yeah, exactly.
And all the aunties and uncles are smack talking each other at the spades table in the corner. It's a gorgeous scene.
Yeah, this is a very fun place to talk about this.
Corinne, thank you so much for coming to the cookout.
I'm so happy to be invited.
Right, so today we are going to be talking about some of the things that you can see in the summer sky, some of the cool astronomical events that will come up this season as we transition into a new season of the year. But there, people might have questions about that. What does it mean? What even is a season?
I know, I do.
Let's get into it.
Yeah, I would love to. I love seeing the stars. It always feels, I think growing up in like kind of a city, it was like really hard to see the sky. We would only see it when we visited my grandparents in the middle of nowhere, Pennsylvania. And I would be like, oh my gosh, there's like stars there all the time.
All the time. Yeah, can confirm middle of nowhere, Pennsylvania does have stars.
Yeah. We were probably looking at the same ones.
Oh my God, we were. Well, definitely we were.
Yeah.
Because you have not spent much of your life in the southern hemisphere,
Not
which
at
means,
all.
yeah, we were pretty much looking at the same sky.
Exactly. Yeah. Okay, so I look at the sky a lot in the winter too, but like it's too cold and I want to go inside and I'm not lingering at all. But what I'm looking at in the winter is not what I'm looking at in the summer, I have to assume.
Correct. Yeah. For most people standing on most parts of the Earth, constellations are only visible for about 6 months out of the year. And that's because the other 6 months of the year, those constellations are behind the sun from our point of view. Yeah, so the time of the year at which you can see a particular target or object in the sky, that depends on its position in space and our position relative to the sun. So over the course of a year, the Earth goes around the sun and different things become visible. This is also why we have like the zodiac signs. There are 12 traditionally, but now 13 zodiac signs that the sun appears to like pass through over the course of a year. So like they appear to be directly behind the sun at different points of the year. But the sun is really big and it's really bright, so it doesn't just block the constellation that is directly behind it. It kind of blocks out that entire half of the sky for half of the year. So that's why you can only see Orion.
Oh.
Orion is my favorite constellation. It is interesting because it can be viewed from pretty much the entire planet, but it can only be viewed at a certain time. It's a winter constellation. It comes out in like late fall, and you stop being able to see it like around this time of year in the summer.
I didn't even realize that. I've definitely been calling any 3 stars in a row in the summer Orion's belt. I don't know what I've been looking at.
You are not alone in that. So like I have a tattoo of Orion on my chest, and it's often one of the first tattoos that people can see of mine, and people can always point out, not always, I'd say like 90% of the time people can point out the 3 stars, and they're like, oh, that's Orion's belt, and I'm like, yes, so this entire thing is Orion. And then but I've seen many people just say like any 3 stars, that's Orion's belt.
Yeah, wow, I've been getting that wrong. I don't know who I've told. I'm like flashing back to just like a 30 Rock style flashback to me telling kids the wrong thing. I never did that.
Never. You were always rigorously fact-checked in real time as the words were coming out of your mouth.
Exactly. Okay, so what can we see all the time?
All the time.
Or year-round, not during the day.
Right. Good catch. Good catch, yeah, because we can't see any night sky objects during the day. You can sometimes see the moon during the day. Like, that is not...
I love when that happens. I feel like I'm in a sci-fi movie.
Because sci-fi movies always have those, like, big objects hanging in the sky.
And during the day, like... Well, I mean, it's like Star Wars, too, where it's like, there's 2 moons.
Yes. Yeah, so sometimes the moon comes out at night. It is not an exclusively nocturnal object. But there are some constellations that are in just the right spot that we can see them year-round. And those are the circumpolar constellations. Those are the constellations that are near enough to the celestial poles. That's like, if you draw a line from our North Pole straight out, North and South Pole straight out, then you get the celestial North and South Poles. And the constellations over the course of a year will seem to just like rotate around the pole. Mm-hmm. It's harder in the southern hemisphere because there is no southern star. But there is a northern star. We have Polaris. And so if you're looking towards the North Pole, you can see the constellations Cassiopeia, Cepheus, Draco, Ursa Major, and Ursa Minor just seem like they're going around in a circle around Polaris. So if you're in the northern hemisphere, you can always see those. And that's because they are north or south enough that they're like above the obscuring line of the sun's light. If that makes any sense.
Yeah, sure. Those names I've heard before, especially Cassiopeia.
Yeah, Cassiopeia is the one that looks like a crown.
Yeah.
Because it's for Queen Cassiopeia. And then there are southern circumpolar constellations too, even though they don't have a south star. There's Carina, Centaurus, and the Crux, also called the Southern Cross. Those are constellations that are always visible around the entire year from the southern hemisphere.
Yeah. I'm realizing how potentially US-centric my vision of the sky is because I'm like, well, you just use the North Star if you were an ancient person navigating the seas. And like, that's not true, I guess, if you're in the south.
Nope, not everyone could do that. Also, our North Star has not always been Polaris. Yeah, there's like this 26,000 year cycle for our North Stars because the Earth, its axis is wobbling a little bit like a tilt. We call this precession. And so over 26,000 years, the line that points out from Earth's North Pole changes. And in like 13,000 years or something, our next North Star is a star called Vega.
Vega, that's a cool name for it. I guess I won't live as long to see see Vega.
You still can do a lot of navigation with the Southern Cross, though, the Crux. There are a lot of really interesting ways that like Polynesian wayfarers or people in Polynesia, they did some cool stuff.
I love that. Okay, so why... I guess we kind of got into this with the sun, but why are some things only visible from certain places?
Yes. So if you have ever traveled from the north to the south hemispheres or vice versa, you'll notice that you see different constellations. You can't see the Southern Cross from the like high northern latitudes and vice versa. So that has to do with the curvature of the Earth. We are stuck on this big round rock and we can't see through it. And so at a certain point when you're looking out towards the horizon, the curvature of the Earth takes the horizon away from you and you can't see behind that curve. And so if you're standing on the equator, if you're standing on Earth's equator, you can see kind of all of the north and south range of the sky. The north and south poles are going to be very close to the horizon from your perspective, but you can still see the entire sky. If you move north or south of the equator, you're going to be blocking some of your view of constellations and other things in the sky. I think it might help to talk about the coordinate systems that we use.
Yeah, let's do it.
Yeah, so there are a lot of different coordinate systems that astronomers use, and I think there are enough to warrant a whole episode about it. But the most common one, and the one you'll see if you Google like the star Betelgeuse's position, it will give you a right ascension and a declination. That is the coordinate system it's going to use. And so right ascension, which we abbreviate as RA, and declination, which we abbreviate as DEC, are the two coordinates that you use in the RA and DEC system. You can think of this coordinate system as like a projected version of our latitude-longitude system. So like if you just take latitude-longitude and project it out to the night sky, longitude becomes right ascension and latitude becomes declination.
Okay.
So right ascension, they make it extra confusing because they don't use degrees as a unit. They use hours, but 24 hours is the same as 360 degrees. It's just like they decided to use a weird unit for some reason.
They just had to do it their own way.
They just wanted to feel special. So right ascension is measured in hours, and declination is measured in degrees, like a normal angle should be. So right ascension tells you like how west or east of the sun an object is, and declination tells you how north or south of our like celestial equator an object is. And so if you are standing, I'm going to use New York as an example because we're both familiar with it. Actually, let's use Pennsylvania. That's where the cookout is. That's where we are. Okay, so we're standing in Pennsylvania. Our latitude right now is about 40 degrees north. And so directly above us right now is an astronomical object that has a declination of 40 degrees north because it passes right overhead. And we can see objects that have a declination of like up to 90 degrees north and down a little bit below the equator, so down to like 10 degrees south or something. But if you're trying to figure out what object passes directly overhead, it is an object that has a declination that matches your latitude, because those are just like 1-to-1. Right ascension is a little bit more difficult to explain because it's based on like the movement of the sun across the sky over the course of a year. And so on the spring equinox, on March 21st, the right ascension of the sun is 0. And then as we move around in our orbit to the summer solstice, that's this week, hello, then the sun has a right ascension of 6. And then in the fall, it has a right ascension of 12. And in the winter, it has a right ascension of 18. And then it goes back to 0 or 24. And so the sun's right ascension changes over the course of a year, and we define a space object's right ascension based on like when it is in line with the sun.
Oh, okay. I think I get it now.
That was long-winded. Did that make any sense?
Yeah, I think I got it. I mean, like, I certainly could not create a map based on this, but I think I have an idea of how they were measuring things. I guess in my head, I would have guessed the sun moves too much to be like a baseline or like a barometer for the location of other things.
It moves a lot from our point of view.
Yeah, but I guess out in space, it's different.
Yeah, this is where I've had so much practice shifting between the Earth perspective and the sun perspective and even like the galactic center perspective. Like I've shifted between all of those points of view. Yeah. And it is really difficult. Like this is something that I honestly struggled a lot with when I was learning astronomy because these coordinate systems aren't intuitive.
Yeah.
It's not really easy, to like project the celestial sphere out there, like it takes practice to do that. So it's fine if you can't draw this map right now. But,
I trust the scientists who made it. And that's all I have to do.
That's all you have to do. Hopefully, if you see the words right ascension and declination or RA and dec, you'll at least know that it means positions.
Yes, exactly.
Yeah. And hopefully you'll remember that right ascension is like galactic longitude or universal longitude, and declination is like universal latitude.
I remember learning about latitude and longitude in school, in elementary school. And my teacher was trying to give us all of these, like, not mnemonics, but like little things to remember which one is left and right and up and down, kind of. And I remember being unable to get it. I was like, you know what? I'm never going to get this.
Oh, no.
Now I get it.
I remember my teacher told us that latitude was the flat one.
That's so good. Flatitude.
Flatitude, yeah.
That's a... Mrs. Sandman. I gotta send her an email.
Hey, I know it's been like 20 years, but here's a way you can improve your teaching.
You're long retired. Okay, so because we talked about this a few times, can you define a solstice for us?
Yes, I can. There are two terms that you might hear a lot in this episode or in future episodes They are solstice and equinox. Every year, as our Earth goes around the sun, we have 2 solstices and 2 equinoxes. There's a summer and a winter solstice, and these are the times when the axis of the Earth's rotation is directly pointing at the sun. So the different hemispheres have it opposite, right? So the northern summer. So right now, June 21st is the northern summer solstice and the southern winter solstice. The southern hemisphere has winter right now. And that's because the northern hemisphere is pointing directly at the sun. And the southern hemisphere is pointing away from it with our 23-degree tilt. So that's June 21st and December 21st. The opposites of those are the equinoxes, the spring and the fall equinoxes, and they happen when the tilt of the planet is like, it's not pointing towards the sun, it's pointing like to the side. It's like, who's the sun? Like, we can't see her, you know? One of those types of things. And so another way that people might think about the differences between solstices and equinoxes is that a solstice is the extreme in terms of the ratio between day and night. So on the summer solstice, we have the longest day and the shortest night. And at the winter solstice, you have the longest night and the shortest day. Whereas the equinoxes are equal in that split. And that's like if you are at a particular point around the equator, you see an equal split between night and day.
Cool. I always love when it's the longest day of the year. Of course, who doesn't? But I feel like it always comes way earlier in the summer than I expect it to. Like, I want it to come in like July, not June. I'm like, no, there's so much more summer to be had. Don't start shrinking.
I was just thinking the other day that the seasons we have and the way we demarcate the changing between them, I feel like it doesn't make as much sense anymore. Like, summer should not start June 21st.
No.
Summer's here.
Summer
starts
Day
in the middle
weekend.
of May.
Yeah. Yeah, exactly. And it goes until mid-September sometimes.
I think we all agree. June, July, August, that's summer. And sometimes summer bleeds into September, which I always think is the beginning of fall. I just think our seasons are off.
They're off. They are. Also, I have a very school calendar view of what a year is. Like, I think a year starts in September and ends in May/June. And then July, August don't count. Like, that is not... That doesn't count towards your year at all. I think that's just fun time.
Yeah. The academic versus fiscal versus like calendar year.
No.
Let's just get rid of it. We don't need an academic year anymore. We're not in totally agrarian society.
No, I know. I think also I just don't want time at all. No time. Hi, it's Corinne. Welcome to this episode's mid-break. I know you can't be at this cookout with us, but I hope you can enjoy some amazing food and go get yourself something cold to drink no matter where you are. I especially hope that our sun-like stars are happy where they are. Thank you, as always, to Sharn Llewellyn, Finn, and Peyton. And thank you to our newest pre-main sequence stars, Levine, Bhatia, and Veronica Chu. You can support us, hear your name on this podcast, and make it to our patron star chart, all by supporting us on Patreon for just about $1 per episode. Find the star chart, Patreon info, and more at our website, palebluepod.com, or by going right to patreon.com/palebluepod. And if you can't support us financially, that's fine. We still love you. You are still space. Another great way to support us is to share the show with your friends. Are you looking for a fun, no-pressure way to learn math and science, besides listening to Pale Blue Pod? Check out Brilliant.org. It's the best way to learn about math and science interactively online. Brilliant has thousands of lessons in math, science, data analysis, and they're adding new ones each month. Enjoy fun storytelling, guided problem solving, and feel free to make lots of mistakes while playing and learning. On Brilliant, your natural curiosity will drive you, not the threat of a test. Brilliant doesn't just teach you facts and formulas, it actually develops your intuition for these subjects through interactive gameplay. Their science courses can help you get a deeper understanding of things we talk about a lot here, like electricity and magnetism and special relativity, or you can branch out to their classes on geometry, foundational logic. Whatever you learn on Brilliant, you'll have a fun time doing it. Go to brilliant.org/palebluepod to get a 30-day free trial, and the first 200 people will get 20% off their annual subscription. Okay, back to the episode. Bye!
So those are, I think, some of the most common questions that people would have about like the changing of the season and why the sky looks different at different points of time and space. Is there anything you want to know more about before we get into what specifically people can see this summer?
That's such a good question. I don't know if I have anything off my head, but I do want to know what I can see when I go outside.
Okay, sounds good. So we have not yet done an episode on constellations. That will have more about like what you can see at what times of the year and from which hemisphere. So I'm not going to tell you like this is when you can see the large and small Magellanic Clouds or whatever. But I am going to tell you about specific events and you know, like kind of transient things that don't happen like every year.
Yeah.
So let's start in June. There were a few exciting things that happened in May, so we missed those a little bit, but we can start in late June. This is a time of year for Venus to really shine. Venus right now is really bright in the western sky in the evening, and that is because it's at something called eastern elongation in its orbit. Meaning it's at the spot in its orbit around the sun where we can see it just after the sun sets. So it's called the evening star.
I have seen Venus at night or like right at sunset around this time.
It's been so nice. I just moved to a new apartment that has a much better view of the sky. And every night I watch the sunset, and then I've been seeing Venus rise over the horizon, and then I've been seeing the moon like come down to meet Venus, and it's been so nice.
I have a skylight in my apartment. It's a small apartment, and this is like the little luxury in it. There's actually two. There's one in the bathroom, and there's one in the living room. And we kind of can sort of lay on the couch at night, and if all the lights are off, you can look out the skylight and see some stars. Aww. You can't like it's a small view, but it is really nice. And once in the middle of the night, I got up to go to the bathroom, and the bathroom was so bright, and the moon was right outside of the skylight. It was crazy. I was like, I should do a spell. I'm not a witch, but like this feels like a spell moment.
Oh, next time, I hope you do a spell. Just like
I gotta whip one out.
Fill a glass with water, put it in the moonlight, and let it
drink it in the morning or something.
Yeah, you can do something with it. It's all about like intentions anyway.
Exactly. I just have to smile while I do it.
Yeah, it's a ritual to make
magic.
You look out for things. Yeah, I love that you have that skylight. I love that I have it too. Beautiful views.
It's really nice. I do feel like I'll need to move soon. But I love this apartment, especially for that reason. I wish I could just, like, attach other rooms to it.
Oh, yeah. You'll find a better apartment.
We will.
Speaking it into existence.
That's the spell, Moiya.
There it is. So, yeah, that is eastern elongation. And if you were to look at a diagram of the sun and Venus and the Earth from the Earth's perspective, then at eastern elongation, it would look like Venus is on the left side of the sun. As Venus goes around the sun, and you know, you have to line up the Earth's and Venus's orbits for this to work, so it's not like every Venus year. But when Venus is on the other side of the sun from our perspective, then it's at something called western elongation, and then it appears just before the sun rises, and it's called the morning star. Like Lucifer, morning star.
I'll never be awake to see that, but I do I do think it sounds nice.
I might occasionally still be up to see the morning star.
That is brave, Moiya. I love going to bed early and sleeping late.
I'm the opposite.
That's so funny.
I love going to bed late and sleeping late.
Yeah, I get it. I'm just trying to stay asleep.
My dreams are nice.
Yeah, it's nice in there.
Venus is not the only planet that you'll be able to see in the sky around this time of year. This month you can see both Venus and Mars, and then next month, starting on July 19th, you'll be able to see Venus, Mars, and Mercury all around each other in the evening sky near the crescent moon. So that'll happen over 3 days, July 19th, 20th, and 21st.
Wow.
And you'll be able to see these planets get like even closer and closer. And then there will be something called a conjunction of Venus and Mars. They'll appear to like pass by each other. Aww. It's going to be really, really cute. Maybe you enjoy watching that and thinking about like the vast distances that you're seeing happen in real time, even though they look really tiny to us. Maybe you're a mythology nerd like me and you're thinking about all of the stories that ancient humans would have told about this very event, like Venus and Mars coming together. Like this is, in mythology, they were having an affair. Maybe this is the conjunction is when they were like getting it on.
Gossip.
There's so much stuff to think about when you're looking at the night sky.
I love that. I think also there's a chance you could be like me and see those 3 planets in the sky and call it Orion's belt.
Yes.
And I hope you don't.
But even if you do, just the fact that you're looking up is beautiful.
You're right. Get rid of my phone neck, too. Just like looking down.
I'm genuinely concerned about that. I think I saw like a 60 Minutes episode.
Moiya, I saw the same thing
15 years ago.
I saw the same thing. I'm like, I'm getting it.
Yeah, about the curvature in our spine at the top of our neck.
Yes. Yeah. I don't know.
Now I'm like that weirdo who holds my phone up to like eye level because I really don't want
Or I'll completely lay down. I'm like, you know what? Maybe I should just lay flat and create no muscle toning at all.
That's fine. That's a great solution.
Yeah.
Moving to August, although it will start in July, we'll be able to see the Perseid meteor shower. This starts in mid-July. It goes through all of August, but it peaks around August 11th or 12th, which is really exciting because I think last year or the last few times that the Perseid meteor shower came by, it peaked around a full moon. So it was harder to see them because the light of the full moon was blocking it. That's why when you went into your bathroom that one night, it was so bright because the full moon gives off a lot more light than a new moon. But it's going to peak around a new moon, so it should be easier to see the meteors, which is very exciting. These are what people used to, or still do, often call shooting stars, although they are not stars. They are chunks of rock, tiny little chunks of rock that are passing through our atmosphere. And this meteor shower, the Perseids in particular, they are caused by Earth passing through a field of debris left over from the comet Swift-Tuttle. Swift-Tuttle passed by Earth in 1992. It left some garbage. It just it's driving by. It throws some fast food wrappers out of the window, and now those fast food wrappers come into our atmosphere and make a pretty light show.
Wait, what was that band that was on a tour bus and they threw all their pee in the river?
What?
Dave Matthews Band. It was August 8th, 2004, and Dave Matthews Band's tour bus emptied the toilet over a river in Illinois, in Chicago, I think.
Over a river. Oh, wait, is this the one where they were like, there was like an overpass, like a bridge or something?
Yes.
Was there a boat? Like, did they drop the pee on someone?
Okay,
is that what I'm remembering?
I'm on a radio station's website, which means it is the most chaotic page you could ever be on. There's a moving thing every few inches. Okay. Passengers on the tour boat Chicago's Little Lady described the downpour of foul-smelling, brownish-yellow slurry that ruined their clothes and made several of them sick.
Oh, no.
This comet is no different.
No different. Just as disrespectful.
Just as rude.
Except I don't know if anyone has ever thrown up from looking at a meteor shower. That sounds
I'll do
awful. All right, well, let's go, Corinne.
I'm so moved
Let's put this
by
to the
it.
test. It did that. It passed by 1992, and we're still passing through its cloud of junk. It passes by the Earth every 133 years. So in the 2120s, it'll be back, and then people will see even more extreme Perseids because there will be even more junk. But right now, there's still enough debris that it's one of the most visible and exciting meteor showers that we get every year. At its peak, you'll be able to see 50 to 100 meteors passing across the sky every hour. So go out. Hopefully you're in a dark enough spot to see it happen. You can see this from most of the planet.
Are these pieces falling through our atmosphere? They're just passing by?
Well, they are kind of stationary in space. They're orbiting the sun, just like the comet Swift-Tuttle does, and Earth passes through that cloud.
Oh, that cloud, I see. Now I'm putting it together.
Mm-hmm. Yeah, no, we're encroaching on their space, you know?
Get out of here again. Every year you come by.
Every year you come by and you burn us up in your atmosphere, and now there's nothing left, and we wait for the next drive-by. It sounds hard to be a debris field out in space.
Seriously. I just started rewatching Smallville, the CW11
the
show.
Superman.
Yeah, the teen drama of Superman.
Oh, wow.
I don't know how long I'll be doing this rewatch. I'm like 3 or 4 episodes in. But it's so funny that every day in this town, one of the teenagers becomes this little monster because of the meteor shower that delivered Clark Kent. And this town is just covered in glowing green, like, rocks and poisoning, like, kids at every turn.
Oh, no. No.
It's a very different vibe than the comets we're, like, pleasantly watching on a summer evening.
I completely forgot that they made a Monster of the Week Superman TV show.
Yes, they did. Boy, did they. I watched it religiously as it was airing, but it's funny how much I've forgotten about it.
Well, maybe there will be a new superhero come to Earth this summer.
I hope.
With the Perseids.
Maybe a tiny baby will fall into a cornfield.
These are very small. Most of them burn up completely in the atmosphere. Most of them do not make it to the surface. Because they are not like comets or asteroids. They are tiny little leftover pieces of junk. Which you will be able to see make this beautiful light show pretty much across most of the Earth. Definitely in the northern hemisphere, that's where it's easiest to see. But going down to the mid-southern latitudes, so like the 40-ish degrees south. Sorry, Australia.
Sorry, Australia. And it's winter for them right now.
It really
Wow,
sucks.
that does suck.
That's okay. I don't feel bad for people in the southern hemisphere because they typically have the best views of the night sky anyway, in my humble opinion. They can see the large and small Magellanic Clouds. I think they can see Andromeda. What's Andromeda's declination? See, this is why it's useful to know the RA index system, because then once you have a grasp on it, you can look up the position for any object in the night sky and figure out if and when, you'll be able to see it. So it has a right ascension of about 1 hour, which means this is Andromeda Galaxy, which means we should be able to see it in the summer, like in June or July is when it's peaking in the sky. But it has a declination of 41 degrees, so you can see it from the northern hemisphere pretty easily.
Cool.
Anyway, I don't feel bad. I don't feel bad for the southern viewers.
No.
They have a beautiful night sky, and they have a cool, from my perspective, upside-down moon.
And they have one of the best Mary-Kate and Ashley movies, which is Our Lips Are Sealed.
So good.
One of the best.
So good. One of the best.
Maybe, I think Billboard Dad might be the only competitor.
But are you counting the ones where they're really little, like the Double Toil and Trouble ones?
No, I'm not, and they're so cute in those.
They're so cute. Little witch costumes. Yeah, this is a longer conversation, Corinne.
Yeah, this is the next movie episode is Passport to Paris, starring Mary-Kate and Ashley.
Oh, what's the one where they're in London?
Winning London.
Winning London was good.
And then, of course, there's Switching Goals, where they are soccer stars.
Can't forget about Switching Goals. Yes.
And then New York Minute, theatrical release.
We can skip New York Minute. There's the one where they go to Utah and they skiing, like road trip.
I forgot
something.
about that one.
Wow.
We got to get them back on the screen.
I don't think they want to be back on the screen.
I don't think they want to be. They are running a very fancy clothing line.
Good for them. Mm-hmm. Probably, I hope.
I think so. I don't know. I feel like any child actor gets to do whatever they want now.
Yeah.
And that's
they've
okay.
paid their dues, for sure.
Okay, back to constellations.
Back to constellations. It is called the Perseid meteor shower because it appears to come from the same part of the sky as the Perseus constellation. That's how a lot of these meteor showers are named. But that is not where it comes from, friends. Please remember that it does. Just because it looks like it's coming from that direction does not mean that it comes from that constellation. It is just a patch of garbage, a patch of refuse, detritus that we are floating through.
Space is too big for all those things to be right next to each other.
Exactly. I wanted to zoom in a little bit from constellations to our moon. August 31st is going to give us a blue supermoon, which, contrary to what some notable science communicators might say, It's exciting. It's spectacular. Don't feel ashamed if you enjoy going to see just like a really big fucking moon. A supermoon is cool. It's nice to see.
When I see a big moon, it feels magical. It's like, this is an incredible moment.
It truly is.
And you feel so weird like texting people and you're like, did you see the moon?
You can always text me that, Corinne.
Wait, did you see the moon?
I love looking at the moon. And when it's closer to us, because that's what makes the supermoon effect. The supermoon is the name for a full moon when the moon is very close to us. So around this time, the moon is at perigee, meaning it's the closest that the moon gets to the Earth because it doesn't have a perfectly circular orbit. So sometimes it's closest to us, perigee, and sometimes it's farther away from us or at apogee. So right now it's closer, so it appears to be bigger. We've talked about the magic of angular size before. If you could get that sparkle back, Misha, that'd be great. But it's a big moon. It's just going to be a moon that looks bigger, and it's called a blue supermoon because it is a blue moon. A blue moon is the second full moon in a month. So August has 2 full moons. There will be one on the 31st and then one earlier in the month on like the 3rd or the 4th or whatever. That's 31 minus 28. And blue moons, you know the saying, like once in a blue moon, they make it sound like it means it's extremely rare. A blue moon is once every 2.5 years.
This is great news. This is really good news for me because I'm like, wow, things happen more frequently than you think. You're like, I'm somebody who, however I'm feeling in a given moment is how I think I'll feel for the rest of my life. And I can't imagine any other emotions. So to know that things happen frequently, to have that data is really comforting.
Yeah. Blue moons happen once every 2.5 years. Solar eclipses, lunar eclipses, they're happening, on the every year to every couple of years range. Like, things happen often.
Good. Good.
And that's most of what you'll be able to see in the sky. Keep a lookout for the Perseids. Definitely keep a lookout for that blue supermoon. It's going to be gorgeous. And in July, around the 19th, look out for Venus, Mercury, and Mars having a little party with the crescent moon in the western sky.
I love it.
I thought that maybe we could end this episode with some of our more memorable experiences. I know you started talking about your times in Pennsylvania, but were there any specific things you saw or like stargazing revelations you had?
I think the most memorable stargazing moment for me was when I first started dating my husband. He always spent some summers in Saco, Maine, as like working as a lifeguard and working as like a janitor and like all these like little kind of summer gigs. And I went to that camp with him a few times and we saw, I don't think I've ever spent a night on the beach before. And the sky is so vast and open, and it was even bigger than how it felt when I would go to Pennsylvania. And I saw like a part of the Milky Way for the first time, which I was so floored by. And I think I've mentioned this in an early episode of the pod, but I didn't know that you could see that with the naked eye. That always felt like some kind of computer rendering to me, or like I just decided that wasn't something that I could witness, especially growing up in New York City where it's like, and even in Staten Island, there's enough light pollution that you're really not seeing anything anyway. But yeah, I just finally had this wide, clear, open view, and I don't feel like I have vocabulary for it. It was so specific and not scary, but it felt overwhelming. Yeah. I just felt so like vulnerable too, of like, wow, I can see so much of this universe and it can see me. I think that was part of it. It was like, oh no.
It's looking back.
Like, suddenly my ego was like, wait a second, we're not that big at all.
Nice. When was that?
That was probably like 5 summers ago. But now I live in Maine and I could probably do that again.
There are some beautiful skies up there.
Yeah.
Yeah, I was never really into stargazing growing up. My mom would try to make me, and I would just be like, it's cold, I want to go inside.
Yeah. Classic.
Classic Moiya. Classic kid, really.
Classic kid, yeah.
I then went to college and I studied it, and I was like, yeah, the science of this, the numbers in this are awesome, but I still didn't really like looking at it. So it wasn't until 2018, I'm in my second or third year of grad school, and I signed up and was accepted for a program called ASAP, where they took science communicators and educators from the U.S. and let them do a tour of different telescope facilities in Chile. So I spent like 2 or 3 weeks down there going to different telescope observatories. We went to see the Blanco telescope, which is on one of these mountains in Chile, and it was so dark that not only did I see the Milky Way, like I had been seeing the Milky Way my entire trip. Like that was kind of old news at that point. I say old news, but it was, like 2 weeks.
Yeah.
And then at this place, it was so dark that I saw my shadow cast by the light of the Milky Way, which was like incredible.
Whoa.
There was, first of all, to be in that darkest spot, I had never experienced that before, but I grew up in the woods. Like, I thought I knew what darkness was. I did not.
You know what dark is,
I did not know what dark was.
Interesting.
So there was that, and then just to have the experience of interacting with photons from like the whole galaxy that are stopped by my body before they hit the ground. Like that's was
crazy.
I felt so powerful and like one with the universe in that moment. It was a very it was an epiphany moment for me where I felt connection to the universe in a way I had never done before, and I saw the value of stargazing for my outreach efforts, because I was like, this is a great way to connect with audiences. I need to learn more about this if I'm going to be a good science communicator.
Yeah, I love that. There used to be like some stargazing meetups near the Brooklyn Museum when I was living there, but it was always on, it was the first Saturday of every month or the third Saturday, and whatever Saturday it was the same Saturday I did astronaut training. So I was like, well, now I have to go host this show about space. And it also meant like I could never reach out to the people who run those groups because they could never do my show.
Oh, damn.
But I did always want to do that. Especially, I think I'd be curious to see how they can encourage that in New York, because I just decided that stargazing was not a part of my life there. Mm-hmm. But there were these groups of people who did it. And I love that.
There are a few around the city, which is really nice. There's a friendly backyard astronomer in New York. I think she's in Brooklyn. But there are a bunch of groups.
I love that.
It's really nice. All right, well, that's all I have. We'll probably do another episode like this for the fall.
Yeah, that would be great. And we can offer some amazing hot cider tips so you can actually stay outside in the cold. Unlike the children inside of us who scream to go back in.
Mom, it's too cold.
Yeah. Well, I see some amazing burgers that are ready for us, Moiya.
Oh yeah, they've done been ready. Corinne, you do have to finish your plate.
Okay, I will.
Okay. All right,
I'm going to take a deep breath and I'm going to do this.
Great.
Okay, well, wherever you're gazing tonight, I hope you remember that you are space.
Bye, everyone.
Bye.
Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.